For the longest time, the whole quantum threat to crypto felt like something out of a sci-fi movie, a problem for another day, right? Well, that conversation has totally changed. It's not hypothetical anymore. It's getting pretty urgent. The timeline is speeding up, and Ethereum is gearing up for one of the biggest, most fundamental upgrades it's ever seen. So let's dive into how Ethereum is planning to face this next great cryptographic challenge. See? This isn't just some academic paper anymore. When Vitalik Buterin, Ethereum's co-founder, starts talking about a detailed emergency plan, you know things are serious. The issue has officially moved from the research lab straight onto the main roadmap. We're talking about preparing for a future that's coming way faster than anyone thought. All right, here's our game plan. First, we're going to get right to the heart of what this quantum threat actually is. Then we'll walk through Ethereum's really elegant plan to basically re-engineer its own security. After that, we'll talk about what this all means for you and your assets. And finally, we'll look at the massive competitive advantage this could give the entire ecosystem. So to really appreciate the solution, we've got to get super clear on the problem. Why on earth is a network worth hundreds of billions of dollars even vulnerable to a whole new type of computer? Okay, so right now, your wallet, doesn't matter if it's on Ethereum or Bitcoin, is protected by something called ECDSA. Just think of it like a super advanced lock. It's built on a mathematical puzzle that's really easy to do one way, but basically impossible to do in reverse. Making your public address from your private key? Simple. But trying to figure out the private key from the public one? No way. No normal computer can do it, no matter how powerful it is.
And then along comes Shor's algorithm. This is the big bad wolf right here. It's basically a recipe, a set of instructions designed specifically for a quantum computer. And what does it do? It solves that impossible puzzle. If you run this algorithm on a quantum computer that's powerful enough, you can take someone's public key and use it to figure out their private key. That's the master key to their entire wallet. Game over.
And the difference in speed here is just staggering. It's hard to even wrap your head around. A classical supercomputer could run for billions of years, literally longer than the age of the universe, and it would never crack a single wallet. A powerful quantum computer, though, it could potentially do it in minutes, maybe hours. The time it takes you to go get a coffee, that is the kind of leap we are talking about. So you might be asking, where would an attacker even get my public key? Well, two places, really. The second you make your very first transaction, your public key is published on the blockchain, forever. It's part of the permanent record. But there's an even more immediate risk. It's called the mempool. Think of it like a public waiting room where your transaction hangs out for about 12 seconds before a miner picks it up. In that little window, your public key is visible to anyone who's watching. All right, so that's the scary part. Now for the really cool part, the solution. And this is what's so fascinating. Ethereum isn't just trying to patch a hole. The dev community is planning what you could honestly call a cryptographic metamorphosis. They're redesigning the whole system from the ground up to be immune to this threat. The plan is incredibly elegant, and it all kicks off with an upgrade called Account Abstraction. This is a game changer. It basically turns every user's wallet into its own little smart contract. Now, why does that matter? Because a smart contract wallet is programmable. You can teach it to understand and verify completely new kinds of signatures that a quantum computer just can't crack. And this is the new toolkit they're building. Instead of the old math, Ethereum is moving to things like Stark-based signatures. These are built on a totally different foundation, like super complex hash functions, which we believe are resistant to quantum attacks. Now, to make sure these new, heavier signatures don't cost a fortune in gas, the plan is to implement them as precompiles. You can think of a precompile like a specialized piece of hardware built right into Ethereum's engine. It makes these complex calculations super fast and super cheap for everybody. Now, this isn't going to happen tomorrow. The roadmap is ambitious, but it's clear. The Pectra upgrade in 2025 is what lays the groundwork with account abstraction. After that, the next big upgrade, Osaka, will officially introduce all this new cryptography. The target for the full migration, when everybody moves over, is sometime between 2027 and 2029. It's a huge, multi-year effort to swap out the very mathematical foundation of the entire network. Okay, so we've covered the threat, we've covered the roadmap. Now let's bring it back down to earth. What does all of this actually mean for you, your ETH, and all your NFTs? This is the million-dollar question, isn't it? With all this massive change on the horizon, do you need to drop everything and do something with your crypto today? Well, the short answer is no, you don't need to panic. But you can start making some smart moves to get ahead of the curve. For holders, you might consider moving your assets from a regular standard wallet to an upgradable smart contract wallet, like a safe. That pretty much makes you future-proof. For everyone, the big takeaway is that this will, eventually, require you to actively move your assets. It won't be automatic. And for developers out there, the message is crystal clear. Start building your app so they can handle different signature types. Don't just hard code the old standard. Let's just zoom out for a second and look at the really big picture. What's happening here isn't just a defensive repair job. If Ethereum actually pulls this off, it's a massive, massive strategic play. I mean, think about it. If this plan succeeds, the world's #1 smart contract platform also becomes the most secure platform against the next generation of computing threats. This creates what you could call a quantum moat. It positions Ethereum as the safe, trusted, default layer for long-term value in a world after quantum computers arrive. That puts it miles ahead of rivals who haven't even started to tackle this problem. But let's be real, we have to be realistic here. This is not going to be easy. For one, the timeline could slip. We know major crypto upgrades often get delayed. Getting millions of different decentralized users all over the world to migrate their funds is a mind-boggling coordination problem. And maybe most importantly, there's a real performance cost for all this new security. These new quantum-safe signatures are much, much bigger. How much bigger? Well, a typical quantum-resistant signature can be around 15 times larger than the ones we use today. That's not a small number, and has very real consequences for things like transaction fees and how much data can fit in a block. It's a serious engineering problem that the core devs are working hard on, but it's a huge hurdle to overcome. So all of this incredible work is happening to secure the network and the assets on it, but it leaves us with one last kind of fascinating question. What about that little physical device you bought for ultimate security, your hardware wallet? Is it really truly ready for a quantum future? Well, the answer might just surprise you.